So we're moving on to day 2 of 12.4. 12.4 covers multiplying and dividing of rational expressions, and so we just take the time to divide it up over 2 days. So today we're looking at dividing the rational expressions we have been working with. So before we get to a rational expression, it would be helpful to remember how it works to actually divide fractions. So when we divide fractions, we don't need a common denominator. We don't just multiply straight across. We actually have to take a look at the fact that there's a division right there, and we end up changing that to multiplication. So if you remember back to our basic fractions, you always keep the first fraction the same. So we're going to have 14 over 3, and instead of dividing, we multiply by the reciprocal. So we're going to take the second fraction, it's always the second one, and flip it. We're going to get 9 over 35. All right, so that's what we're doing today, is we're taking our division, changing it to multiplication, and flipping our second fraction, or rational expression, and then we're going to simplify and do the multiplication the way we did the last lesson. So for this particular example, we could do some cross multiplying, or cross reducing. 3 fits into 9 3 times. And 14 and 35 can both be divided by 7. 14 divided by 7 is 2. 35 divided by 7 is 5. And then you would multiply the numbers you have left over, 6 over 5. So that's just a reminder on how it works to divide fractions. Now we're going to take a look at some rational expressions. So we see that we are dividing by another fraction, so what we want to do is completely rewrite the entire problem. The first one stays the same, 3x to the 4th y over 2a squared z cubed. Change that division in the middle to multiplication. We're going to multiply by the reciprocal, and then we're going to go ahead and flip the second fraction. 8z to the 4th over 12x squared z. All right, so now that we're multiplying two rational expressions, first look to see if you can do any factoring. If you notice, we don't have any addition or subtraction in here, so no factoring to be done, so we'll just multiply straight across and reduce our answer. So multiply the coefficients first. 3 times 8 is 24. Then we can multiply our x's, our y's, and our z's. You might notice that there are no x's, y's, or z's to actually multiply, so those all stay the same. We're going to put this over our denominator and start by multiplying your coefficients. 2 times 12 is 24. X squared, I have a random a in here, that's nice. A squared. And then z cubed times z is z to the 4th. All right, so now we're going to work on simplifying this. Do we see anything on the top that can cancel with the bottom? Or actually in these we go left to right. 24 divided by 24 is 1. I'll go ahead and write it as a 1 over 1 for now. X to the 4th over x squared. Subtract your exponents, you get x squared, 4 minus 2. Now we have a y. Our y doesn't have anything to divide with, so the y is just going to stay up there with the x squared. I notice there is an a squared on the bottom. There's not an a squared on the top to divide with, so that a squared is going to stay on the bottom. And then we have our z to the 4th over z to the 4th. So z to the 4th over z to the 4th, we actually are just going to go ahead and cancel those, and the z's are gone. So our answer, we have 1x squared y, or just x squared y, over 1a squared, same thing as a squared. So that is our final answer. Very similar to what we did in the last lesson, only this time we just have to flip our second fraction and change it into multiplication. All right, I'm just going to do one more in the intro video, and then there's another video with a few more examples to take a look at. So divide, always factor first if possible. So I know that I have to rewrite this problem because we have to multiply by the reciprocal, but I'm going to be a little bit efficient with that. As I rewrite the problem, I'm going to go ahead and factor it as I go along. So first I'm looking at 2m cubed plus 2m. we can take a GCF out of 2m, and it leaves us with m plus 1 over, now I've got m squared minus 2m. Again, we can take a GCF out of m, it leaves us with m minus 2. All right, I'm going to change this to multiplication, and this fraction up here, we're just going to flip that. So that m minus 1 on the bottom ends up going on the top, and it can't be factored, so I'm just going to write it as m minus 1 over. Now, 4m squared plus 4, as I write that down, I'm going to go ahead and factor it. I factor out of 4, it leaves us with m squared plus 1. All right, so now, just like the problems from the previous lesson, I'm multiplying two rational expressions. I can go ahead and make this one big fraction and then see what I can cancel between the top and bottom. It actually doesn't look like a whole lot. I see we have an m that will cancel out with an m. We've got a 2 right here and a 4 right here we can reduce. That would become 2 divided by 2 is 1, 4 divided by 2 is 2, and I believe that's all that we can do. So on the top we are left with m plus 1, m minus 1, and on the bottom we're left with a 2, an m minus 2, and an m squared plus 1. So we didn't get a whole lot to cancel out on this one, but that's okay. We took care of all of our factoring, flipped and multiplied, and reduced our answer by canceling out what was in the numerator and denominator. So make sure you watch the other video carefully just to get some more examples. In case there's anything tricky that shows up, it'll be covered in the other video.